Okay, elimination, you guys, is another method for solving systems. What's the first method that you guys learned? We've learned one way of solving systems already that are similar to this. What's the method called? You guys know? Substitution. Good. So in the past, we've used what's called substitution. So be sure you read the directions, because some in the book are going to say solve by substitution, and some are going to say solve by elimination. I personally prefer elimination. Okay? Another word that I've heard used for elimination that you might want to write down is called linear combinations. Okay? Just in case you guys ever see another textbook that uses that, it means the same thing as elimination. Okay? But you will probably see elimination in this book. All right, so to use elimination, what we're going to do is I want to cancel either my x's or my y's. I typically pick the smaller numbers. So when I look at the x's and when I look at the y's, which ones are like smaller numbers, which means it's kind of easier? The x's, okay? So the goal is to get two numbers that will cancel each other out. So 3 and 2, what's the smallest number 3 and 2 go into? 6. So what I want to get is a positive 6 and a negative 6. So when I add down, it cancels, okay? So if I want to get 6 for my x piece, I would have to multiply this equation by 2, okay? And I can't just multiply the x. The only way to legally do this is to multiply everything by 2, okay? All right, and then in the bottom equation, I want to get negative 6, because now I'm going to have positive 6 in the top. I want to get negative 6 in the bottom. What number, if I multiplied by 2x, would give me negative 6? What would I have to multiply by? Isaac? Negative 3. Okay? So 3 would give me 6, but I want to make it a negative so that they can cancel. All right? So let's multiply the top equation by 2. And I'm going to rewrite this equation, okay? So I have to multiply every single thing in the top by 2. What does that give me? I'm going to write it down here. That gives me 6x. How about for the y's? What do we get? 8y. And how about over on the other side of my equation? What do we get? Negative 14. All right, that's an equivalent equation right there. I just multiplied by 2. All right. Now we're going to multiply that bottom equation by negative 3. So what do I get when I multiply this to this? Negative 6x. How about negative 3 to 3y? What do we get? Negative 9y. And how about all the way over here to my other side? What do we get? 18. It is a negative times a negative, so it gives me positive 18. Now this problem is so much fun. Woo! What happens when I add these equations together? What happens to my x's? Yeah, 6x minus 6x is 0. You don't have to write it down, but it cancels. And then when I add down with my y's, what's 8y minus 9y? Negative 1y. And now I add these numbers. What's negative 14 plus 18? 4. Good. Now this becomes an easy algebra problem to solve for y. I'm going to divide by negative 1 on both sides. So y equals negative 4. Okay? Now we're not done, because anytime you do substitution, this is the same type of problem. What do I have to do after I find one of the variables? Got to find the other variable, plug it in. It's easier to go back to one of the original equations up here. So I'll just erase so you guys can see the original equation. So we just found that y is negative 4. This equation looks a little bit easier to me because the numbers are smaller. Doesn't really matter, though. You'll get it right either way. So I'm going to use the second equation, and I'm going to plug in that y is equal to negative 4. And we're going to solve. Okay? So I do want to see your work on this part. So 3 times negative 4 is negative 12. What would we do next? Add 12. Good. So we get 2x equals 6. What would we do next? Divide by 2. So we get x is 3. And don't forget to get this problem fully right, you have to write it as a coordinate, x comma y. So in order to write it as a coordinate, 3 goes first, negative 4 goes second. Okay, we're good to go. That is called elimination. Let's try another one. So write that one down. Okay, so we want to cancel either the x's or the y's, and we want to pick whichever has like the easier numbers, right? So Julia, what's easier to cancel, x's or y's? Probably the y's, right? It doesn't really matter, okay? If you cancel the x's, you'll get the right answer. But let's cancel the y's this time around. So I've got a 2 and a 3. So Caleb, what is, actually we did one similar to this last time. Let's cancel the x's because 2 and 3 was 6 last time. Let's do the x's. All right, I want to cancel x's. So I want to do 5 and 2. So Caleb, what's the smallest number 5 and 2 go into? 10. So I need a positive 10 and I need a negative 10. And it doesn't matter which one you do positive and which one you do negative. Okay? So Jackie, what do you want to multiply the top by? 3 would give me 15, which 2 doesn't go into. I want to get 10. 5 times. Good. So 2. And then the second equation, Sophie, what should I multiply this one by to get negative 10? Very good. Negative 5. So we're going to rewrite the equation. So Josh, tell me what you get when you multiply every single thing in the top by 2. 10x plus 4y. Very good. So I distributed the 2 all the way across. Okay, Nico, tell me what you get when you multiply everything in the bottom by negative 5. Be careful with your signs. Very good. So right here, it's a negative times a positive. You guys, you don't have to put plus a negative. Just put a minus sign. Okay, that's a negative. And then a negative times a negative is positive. All right, now we can add the equations together. So Drew, what happens to the x's when I add down? They cancel out. Alex, what do I get when I add the y's? Negative 11y. Okay, good. And Leah, what do I get when I add these numbers right here? We actually get positive 44, but yep, okay, positive 44. And divide by negative 11 on both sides. So what is y equal to, Jordan? Negative 4. You can plug into any equation, but it's easier to go back to one of the original equations. I'm going to do this one right here. I'm going to plug in here. So 2x plus 3 times negative 4. Someone's phone ring? It's been like forever. Someone is super popular and needs to be gotten a hold of right now. All right. So 3 times negative 4 is what, you guys? Wow. All right, what do we do next? All right, you guys solve the rest of this. Riley, solve it for me. Tell me what you get for x. Okay, I like your answer. So we'd add 12, right? Add 12, 2x equals 2. Divide by 2, and x is 1. All right, final answer, though, Dylan. What's my final answer here? What do I have to write down? Very good. Okay, that is called what? What's this method called? Elimination. All right, we're going to do one more because it's different. Write it down. This one has one where it's actually easier to cancel one of them because we only have to multiply by one equation if we choose one of the variables correctly. So, Ben, do you think it's easier to cancel the x's with the y's? You are correct, okay? It is easier to cancel the y's. I have a negative 1 in front of this y and a 4 in front of this y. What's the smallest number that 1 and 4 go into? 4, right? I already have a positive 4 here. I've got a negative sign here. That's also really nice. There's already a negative. What do I need to multiply this top equation by to cancel the y's, you guys? A 4, because that would give me a negative 4y, and that's how we're going to cancel it, right? So we're going to multiply the top by 4. So Aaron, what do I get? Go ahead and multiply each thing by 4. I'll help you out with the last one if you don't know it. What's this? 8x. Uh-huh. Anybody know 13 times 4, you guys? Yeah, deck cards, right? 52. Okay, we're going to rewrite the bottom equation as is. So we're actually not multiplying anything by the bottom equation, so that's nice. just rewrite it underneath the one you just wrote down. Okay, you do have to line up your equations. Now we add down, Sophia, what do I get for my x's? 11x. My y's cancel out. And Evie, what do I get for this part here? Good, 55. Okay, we're going to divide both sides by 11, so x, Riley, equals what? 5. Okay, go back, plug in wherever you want. I'm going to use this second equation right here. So 15 plus 4y equals 3. Subtract 15. 4y equals negative 12. Divide both sides by 4, y equals negative 3. So my final answer, Andrew, would be what? Very good. 5, negative 3, write it as a coordinate point. Let's try